So good day everyone. So we already answered our part A. So now we're going to answer part B. Okay. So in part B, so for the exercise 3.3 part B, so under chapter 3 motion into or three dimensions, section 3.1 position and velocity vectors for part B, find the magnitude and direction of the instantaneous velocity at t is equal to 0, t is equal to 1 seconds, and t is equal to 2.0 seconds. Okay. So from our lesson, so we know that that the the instantaneous velocity vector v is just equal to the derivative of the position with respect to time. Okay, so that is our instantaneous velocity. Here, we know that our position or is 4.0 centimeter plus 2.5 centimeters per second squared, okay, t squared, okay, I hat plus 5.0 centimeters per second times t j hat. Okay. So the derivative of the first constant is 0 here. Okay. 0 plus the derivative of this term here is just so let's make it clear. So this is 2.5 so that there is no misconception. This is 2.5. So, so you bring down the 2. So 2 times 2.5 centimeter per second squared. And we have 2 minus 1. So just 1 or t to the power of 1. So we're not going to include the power 1. I just put as t. I hat plus for the second. The derivative of this one is just derivative of t is just 1. So we have 5.0 centimeters per second. Okay, j hat. So these are our, so we can simplify this further. So we have 2 times 2.5. So we have 5.0 centimeters per second squared. Okay, centimeters per second squared. Okay, times t. Okay, I hat plus 5.0 centimeters per second. Okay, j hat. Okay. So if you want to find the magnitude and the direction of the instantaneous velocity so this is now our velocity as a function of time, our instantaneous velocity. So when our velocity when t is equal to 0, we call this one as v sub o, v sub 0. So we have actually here, if we substitute t is equal to 0, so the first term will become 0 and the second term will become the same plus 5.0 centimeter per second j hat. Okay. So for v, t is equal to 1, we call this one as v sub o1. So we have here 1, so we have 5.0 okay, centimeter per second squared times 1. Okay. So times 1 is equal to the same. So I hat plus, so the same. It's not a function of anything. It's not a function of time anymore. Okay, j hat. Okay, j. So here, when v is equal to t is equal to 2.0 seconds, we call this one as v sub 2. Okay, so here we have 2 times 5, so we have 10.0 centimeters per second squared. So actually, uh, this will become seconds because we have here second. So seconds will cancel out. So we will have now seconds. Okay. Plus 5.0. So this is I hat plus centimeters per second kj hat. Okay. So we have here uh the we have here values. Okay. To find the magnitude of the V sub O, okay, you want to find the magnitude of V sub O, is the square root of just this the square root of uh, 0 squared plus 5.0 centimeters per second squared. Okay, that's the magnitude. So it will give us 5.0 centimeters per second squared. I mean per second. Sorry for the misconception. It's per second. Okay, meters per second. Okay. So for the if you want to find the magnitude of V sub 1, so you have the square root of 5, so 5 centimeters per second squared plus 5 centimeters per second squared. So you will have, so I think I guess 7.1. Okay, 7.1 centimeters per second. Okay. You want to find the magnitude for the V sub 2. Okay. So we have 10 centimeters per second squared plus 5 centimeters per second. Okay, second squared. So it will give us, so this is will become 10, will give us 11.2 centimeters per second. Okay, so to find the magnitude, okay, to find the magnitude, so let's graph this one. So here, this is actually y and this is actually x. So here, for our v sub o, so our v sub o x is 0. So this is our v sub o, v sub 0. This is actually v sub 0 y. Okay. So here, we know that it only lies on the x-axis. So because it has no y-axis because it has no x component. So meaning this is actually 90 degrees. So the direction theta is 90 degrees. Okay, here, using this formula, uh, theta is equal to the tangent of this uh, v sub v sub n, okay, y over v sub n x. Okay, so n is equal to uh, 0, 1, 2. Okay, so I mean 1 and 2. So so here, for example, you want to find the magnitude here. So both are positive. So they are both in positive. This is our v sub 1 x and this is our v sub 1 y. Okay. So our v sub 1 vector, v sub 1 vector is right here. So we calculated that one. This is equal to which is equal to 45 degrees. We already calculated this one, 45 degrees. So theta is equal to 45 degrees. Okay. How about for letter C? So here let's graph the vector. Okay, let's put this way here. So here we have positive and positive also, positive and positive. So our V2 is on the first quadrant. So we have here tangent inverse -1. So we have here our y is 5. So 5 over 10. Okay. Centimeters per second. So we have, so shift tangent. So tangent of 5 So we have 26.6 degrees. So 26.6 degrees. So here the theta is 26.6 degrees. So here the theta is 26.6 degrees. So we're gonna continue this problem. And letter C, problem, we will continue this problem. We're gonna answer letter C in the next video. So please click like and subscribe to our channel for more videos like this.